Welcome to the video lesson on Unit 3.7B. That's right, this is day 2 of the point slope form. Since this is the second time we're looking at this material, we're going to move a little bit faster through some of these notes. Point slope form is y minus y1 equals m times x minus x1. The x1, y1 represents a point on the line, a specific point on the line. The slope is m as usual. That's the rise over run for the graph, how the line is changing from point to point. And then the x and y without the little ones, this x and this y, it stays in the equation because it represents the fact that there are hundreds of thousands of infinite points on each line. So the first job will be for us to be able to identify the slope and a point given point slope form. So you can see here in the black ink, y minus 1 equals 3 times x plus 6. So I just wrote in blue underneath it, the y minus y1 equals m times x minus x1, and then I circled the match. So m matches up with the 3, so that's my slope. It's always the number in front of the parentheses. And then remember when we pull our x and y, the tricky part is that the formula, the point slope form, has subtractions in it. So you really always have to take the opposite of what you see. So I see a plus 6, which actually means my x value for 6 is negative. I see a minus 1, which actually means that my y value of 1 is positive. Same thing over here. Took my original equation. Underneath it, I wrote the point slope form just so I could match things up. My slope is negative 2. My x value, though it looks like a negative 2, is actually positive. And my y value, it says plus 3, means that it's actually a negative 3. So slope, the point, slope, and a point. The last two, I just did the same thing. So I got 2/5 as my slope, a positive 1 and a negative 4 as my point, a negative 5/6 as my slope, a negative 6, and a positive 1 for my point. Go ahead and pause the video and try to identify the slope and a point from these 3 examples. Please pause the video and try it on your own. Checking your work, you should have m is negative 4, the point negative 3, negative 5, m is 3/4, with the point negative 2, negative 7, m is negative 2 through the point 9, 6. The deal with point slope form is that it's very useful if you need a point and a slope, or if you're given that information in this form, then you can very quickly graph. But slope-intercept form, which remember is y equals mx plus b, is the most common form of the equation of a line. So it is important that we understand how to convert a point slope equation into a slope-intercept form one. And remember, it was really just 2 steps. We distribute the slope through, and then make sure that we're using that calculator. It should only be one calculation for the calculator because the first one is just being multiplied by the letter x. So we literally just put the letter x next to it. But negative 6/5 times negative 5, you'd want to put in your calculator to get positive 6. Then ultimately we just need to get y by itself. So you just have to add or subtract whatever number is over here with the y to move it to the other side. Keep in mind here that it is a constant. There is not a variable on the 3 here. So it needs to be subtracted from the 6, not the x. So it does not have any variable on it. It needs to be added or subtracted to the other constant. And then we're done. Y equals negative 6/5 x plus 3 is the slope-intercept form equation for this exact same line. So let's try it over here with this example. First thing we're going to do is distribute the 9/7. So since I'm not doing anything with the y minus 4, that just gets written down. When I multiply by x, I just put an x next to it. And then what I would be putting in my calculator here is 9/7. I would do it times negative 14. But however it is, you need to realize that your answer should still be negative, so we're still going to have a subtraction there, and it should be minus 18. Okay? Now, second step is just to add 4 to both sides to get y by itself. So y equals 9/7 x minus 14. Okay, and just remember that this, like we're doing this adding a 4 because it's inverse operations so that these equal 0 and they add or subtract out depending on what the problem is. 2 more examples together, distributing first, then isolating the y. Again, distributing first, and then isolating the y. Notice that I got a fraction after my distribution. Here, -1/4 times +6 is -3/2. I kept it as a fraction. I understand your calculator would give you a decimal back. Since it ends up being the value for b, it does not technically matter, and whichever way you are using it in your calculator is fine, and we should end up with -1/4 x plus 1/2. So again, pause the video, convert the following equations into slope-intercept form. It's 2 steps. We should be distributing, and then we should be isolating. Distribute and isolate, distribute and isolate. Check your answers. One thing I will point out with the second problem here is that I did decide to leave my answer for b in fraction form. If you got that as a decimal, it's -5.5, so 3/4 x minus 5.5 would be the decimal form for that answer. Now moving on to graphing. Remember, there are 2 methods to graphing equations from point slope form, and the first one that requires the least amount of work is to use the point and the slope. So again, identifying, this is what we did in the very first example. My m is 1/3, and based on taking the opposite of what's there, my x value is +6 and my y value is +4 for my point. So when we are graphing, we simply put a dot at the point 6, 4, and then we use the slope of +1/3 to get more points. So I jumped up 1, and then I jumped to the right 3, and that is where my next point would go. And if I wanted points in the opposite direction, I would go down 1 and to the left 3 to get my other points. Okay, and then I can just connect them with a line, and I can keep going actually to get more points, down 1 and to the left 3, because I had a lot of space in that direction before I decided to connect them with a line. So that's the graph of the equation y minus 4 equals 1/3 x minus 6. So in the second one, still using the point and the slope, we should get -4 as the slope, -4/5 as the slope, and +5, -2 as the point. So again, I'm going to start at 5, -2, and then I will count down 4, 1, 2, 3, 4, to the right 5, 1, 2, 3, 4, 5, and that is where I will put my next point. And then to get points in the other direction, instead of going down, I will go up, 1, 2, 3, 4, and instead of going to the right, I will go to the left, 1, 2, 3, 4, 5, to continue with my 4/5 slope. And I can do that one more time to get another point, and actually go up one more time, up 4 and to the right 5, to get 2 more points before connecting them with a line. So that is the graph for the equation y plus 2 equals -4/5 times x minus 5. The second method requires a little bit more work, because what we're going to want to do first is turn it into slope-intercept form using those 2 steps of distributing first, and then isolating the y. And then when we get it in slope-intercept form, now we can just start at the y-intercept of +3, put a dot there. So it's just your first dot is in a different place. When you're using the slope-intercept form, the first dot is on the y-axis. If you're using the point and the slope, then your point is just a random point on the line. But I'm just going to use my slope, +2, to go up 2 and to the right 1, or down 2 and to the left 1. And I'm just going to keep going just to practice counting my slope before I connect them with a line. So that is the graph of the equation y minus 5 equals 2 times x minus 1. It's the equation of y equals 2x plus 3. And just to show you what I mean here, if I were to get the point from this point slope form, the point would be +1, +5. And if I come over to +1 on the x-axis, and I go up to +5 on the y-axis, there's that random point. So it just proves that the point 1, 5 is on the line that we get when we transfer it or convert it into slope-intercept form. In this last problem that we're going to be graphing together, still turning it into slope-intercept form, it is important to realize that this is not just a negative symbol here. It is technically a -1 that is going to get distributed to the x and the -3. So when we do that distribution, y minus 2 equals -1x, and you don't have to write the 1 there. That's why it's not there in the original problem. But just so you know, we did multiply that negative through, so we end up with a +3, Then I can add 2 to both sides to isolate the y. And we're isolating the y again just so that it starts to look like slope-intercept form. So in this case, I'm going to start my graph at +5. And I have a slope of -1, so it's going to go down and to the right, down to the right, consistently over and over again, or up and to the left, consistently and over again. And I can use those to connect to make a line. So that is the graph of the line y minus 2 equals -1 times x minus 3. It's the same for y equals -x plus 5. And again, just to prove it, the point that's given in that point slope form is the point +3, +2. So if I come over to 3 on the x-axis and 2 on the y-axis, that's the point right there that is given in the point slope form of that line. So go ahead and graph these 4. You can use either method, it does not matter. Go ahead and graph them. Pause the video, please. Go ahead and check your answers. As you can see with my work, I decided to do at least just this one with turning it from point slope form into slope intercept form. And I was going to do it again here in this last problem, but I realized I didn't want to multiply fractions. And that's actually here. Like if I really thought about it, these would have been the ones that would have been very simple to turn into slope intercept form because of the simple distribution. When I'm multiplying fractions here, you might have to grab your calculator, making it a little bit more time consuming. It doesn't matter, again, which method you were using here, but I think we'd all have to agree that if it's in point slope form, the fastest way is just to grab the point and the slope and graph it using that method. This concludes the video for the second day on the point slope form, which is y minus y1 equals m times the quantity x minus x1.